Hey folks, Mrs. White here. If you are watching this right now, you chose to kind of continue in Algebra 2 with like the traditional track, where we're just going to cover Chapter 5 and hopefully Chapter 6 before the school year gets out, or at least parts of Chapter 6. Um, so I'm glad to have you here. If you weren't already in my class, I want to give you some information about this class. I'm releasing new materials on Monday and Wednesday. So twice a week, you'll get a Google Classroom notification saying that I've released an assignment to you. It'll be something like this, where I'm going to give you a little video. It can be anywhere from 30 minutes to an hour. It will never be longer than an hour, which would be a normal class period. And there will be a homework assignment attached to it. Okay. And that homework assignment will be due before the following class. So if material is being released on Monday, like this video is going to, you'll watch the video on Monday, you have Monday night, and really all day Tuesday and Tuesday night to work on this homework. But however, before material is released on Wednesday, you need to make sure you turn in this homework. Okay, so this would be due Tuesday by midnight. On Wednesday, I'll release new material, but we don't have anything else released again till Monday, so technically Wednesday night's homework isn't due till Sunday. Okay. I will be checking off homework Monday morning and Wednesday mornings for your class, and that's why I made the due dates when I did. You're welcome to turn in anything late. That's perfectly fine with me. I really just want you getting the practice. And that's why I'm pre-recording these videos too, because not everyone can be live for a Zoom class, so the videos will always be pre-recorded. Okay. I am offering what I call office hours. That's going to happen twice a week in between when I release new material. So it'll happen on Tuesdays and it will happen on Thursdays from 1 to 2. I'll send everyone in the classroom an invite to the Zoom meeting. And this is where you can ask questions about the classwork, about the homework, about upcoming assessments, about whatever you need to. Okay, so I will be available just for Algebra 2 College Prep from 1 to 2 Tuesdays and Thursdays. And feel free to check out the calendar I created. That kind of outlines what we're going to be doing over the next few weeks. And that also lets you know when the office hours are. So I'll put that right up in the classroom so it's available to you also as some of the materials available. So today we're going to start off Chapter 5. Okay, and Chapter 5 looks at operations with functions, so things like adding, subtracting, multiplying, and dividing with functions. And this is going to be really similar to computing with polynomials, which was a big part of Chapter 4. So today is kind of a nice way to ease into some new stuff. We are going to look at a couple word problems, depending on how long this video ends up going, and looking at how adding, subtracting, multiplying, and dividing functions can create new functions that can be used in the real world. And so we'll talk about that as we get to it. You do have homework tonight. It's 4 through 13 odd in your ebook, page 318. If you're struggling with access to that ebook, reach out to me. I can figure out your login information for anybody, whether you were originally my student or not. Okay? We are going to start off today with a sit and begin, and usually a sit and begin is going to be some sort of review from a previous class or from a previous chapter. So our sit and begin today has us looking at a factoring problem that you would have seen on your Chapter 4 test. So, when we are asked to factor something, the first thing you should be thinking always, every time, regardless of what this looks like from the get-go, is can I GCF it? Can I pull out a greatest common factor? So the first thing you'll do is you'll look in all the pieces of your polynomial, whether it's 2 or 3 or 5 or however many, and you're going to look for common variables or common constants that can be divided out of your coefficients. So here we have just x and we have just y. Because x doesn't happen here and here, or y doesn't happen here and here, I can't GCF out either of those variables. They don't occur in all the pieces. However, 48 and 12, those two coefficients, are both divisible by 12. So I can actually GCF out a 12, and I will be left with 48 divided by 12, which is 4, x to the 4th, because that doesn't change, minus 12 over 12, which is 1. So it'd be like negative 12 over 12, which is negative 1. We keep that minus there. Those cancel, okay? And we just have a y to the 6th. Now at this point, folks, is when a lot of people are curious about what do I do now, okay, after you GCF? Well, you should have two things that you notice. One, you should notice that this is two pieces and that it's a difference. So it's either a difference of squares or a difference of two cubes. Okay, those are your only two factoring strategies that would work with two pieces where it's subtraction. Now, the way that you decide which one to do is you look at these exponents and you ask yourself, are both of them divisible by 2? If they are, it would be a difference of squares, or both of these divisible by 3. If they are, they're a difference of cubes. If they're divisible by both, that means you'll probably be able to do both, but you should probably start off with the cubes. So I noticed that both 4 and 6 are both divisible by 2, which means that this potentially is a difference of squares. So I'm going to pull a square out of each chunk and keep the minus sign here to show that it's a difference, and I'm going to square root each of these pieces. So I start off with my constant. What's the square root of 4? Hopefully you're hollering at me saying 2. Then I'm going to ask myself, what's the square root of x to the 4th, or what times itself gives me x to the 4th, and the answer to that is x squared. Coming over here, y to the 6th, I would ask myself, what squared, or what times itself is going to be y to the 6th? Well, that's going to be a y to the 3rd, okay? Because for 2 reasons. If you have y to the 3rd times y to the 3rd, okay, our exponent property here, when you multiply like bases, is to add your power, so we would have 3 plus 3, which is 6. You also could look at this problem where we have a power to a power, and our exponent property tells us that when we have an exponent raised to another one, we multiply those to get to 6. So regardless of how you think about it, whether you remember power to power or multiplying like bases rule, either way it works, okay? Now because this works and this works, that means it is a difference of squares. We're going to treat this chunk like our A, this chunk like our B, and remember that a difference of squares is always A plus B and A minus B. That's our shortcut. So now we're going to be ready to go right down to our answer. I have my 12 out front. Then I'm going to have A plus B, but instead of A, I'm going to put in 2x squared, plus instead of B, I'm going to put y to the 3rd. Then I'm going to have A minus B, so instead of A, I'm going to put 2x squared again. And instead of minus B, I'm going to put minus y to the 3rd. Now at this point, I notice that my exponents aren't all 0, okay? Or not 0, they aren't all 1, which means that there's potential that I could continue to simplify this. Now, I could have a sum of cubes. I notice this is a cube, but this is not a power that is divisible by 3, so it can't be a sum of cubes. So over here, this is a difference. It could be a difference of squares or a difference of cubes. However, if I look at my powers again, right, they're not both divided by 2 or both divided by 3. It has to be able to happen to both of them. And since that's not the case, I cannot factor this any further. I am done. Okay, so this is where that problem should have stopped. Now, let's go forward with section 5.1. Okay, in 5.1, we're going to look at how do we add functions, how do we subtract functions, how do we multiply functions, and how do we divide functions. And we've actually done all of these because the functions we're going to be dealing with are going to be polynomials, okay? The biggest difference is going to be the notation. So let's take a look right here. Okay, when we're dealing with functions, we're dealing with function notation, which means it could look like this or this. This would be like our parent function, f of x equals 2x, and then our other parent function would be g of x equals negative x plus 5. So right here, this would be what you're asked to do, f plus g of x, and that's how we would read it, f plus g of x. And what it's telling us to do is take our f function, right here, take our g function right here, and add the two together. It's pretty straightforward. F of x plus g of x is essentially what we're doing when we see this notation. So if we're going to do that, we're just going to add these two things together. I'm going to take my f of x, which is 2x, and I'm going to add to it negative x plus 5. Now, when I add it, because this is two pieces, it's a binomial, I'm going to write it in parentheses. I did not do that with my first piece because it's only one chunk. It's a mono. So I would ask myself, is there anything I need to distribute here? When I'm adding, you don't have to distribute an addition sign. So really, all I need to do is combine like terms. I can ignore that and ignore that. So I have 2x minus 1x, which is just going to be x. And then I just have a constant of 5. So my answer is x plus 5. Okay. Now, if we're dealing with function notation, we really should write it with our input and our output together. So my answer should be f plus g of x equals, and then the x plus 5. So this would be what your answer should look like in your notes. F plus g of x equals x plus 5. Input and output. Let's take a look at subtraction. It's going to be super similar to addition. Okay, if we look again at this notation, right, we see f minus g of x. So we're going to take our f of x and we're going to subtract from it g of x. Okay, so we'll start off, and the order of subtraction matters, so be very thoughtful on how you write things. I'm going to start off with my 2x, and I'm going to subtract from it negative x plus 5. And this is an example of where you really do need to make sure that you put those parentheses in there. Because when we're subtracting something that's more than one piece, we need to make sure we distribute the negative to both pieces. So this actually becomes 2x plus x minus 5 once we distribute that negative across. Now we're ready to combine like terms. I have 2x and a positive 1x, so I'll have 3x's. And then my constant is now a negative 5. And if I want to write this answer in function notation, I should have f minus g of x equals, and then 3x minus 5. Because remember, function notation is a relationship between input and output. You need to show both when you're showing your answer. Let's move on to multiplication. Again, you know how to do all of this work. Okay, so f, and then this little dot is the multiplication symbol, g, so f times g of x is just saying take your f function and multiply it by your g of x function. Okay, so there's what our label will look like, and that's the question it's asking us to do. So I'm going to take my f function first, my 2x, and I'm going to times it by my g of x function. Now I'm fortunate here again because my f of x is a monomial, right? It's one chunk. So all I have to do is distribute it. However, if this was 2 pieces, folks, and this was 2 pieces, I would make sure, or have to make sure, to double distribute. Or some of you might know that as foiling, right? Where you do first, outside, inside, last. But really, you just need to make sure you multiply every piece by every other piece in the other polynomial. And we'll see some examples of that in this presentation. So I'm going to multiply this across to both pieces. So 2 times negative 1 is negative 2. X times x is x squared. 2 times positive 5 is positive 10. And then there's no x with the 5, so I just bring the x over. That is the answer to f times g of x is going to be negative 2x squared plus 10x. Again, we should write that in function notation. The last one is division, and you're going to want to do more here than you normally do. What we're going to do is we're going to write f divided by g of x. Okay, so we're going to put our f of x over our g of x as one big ratio, right? One big fraction. Then we're going to see if we can factor either of the two and have the factors cancel out. We're not going to worry about doing long division or synthetic division here, okay? We're just going to look, can it be factored, and can I simplify a factor out of the numerator and denominator, okay? And we're going to worry about this little piece in a minute, okay? So just hold on to that if you're curious about what that is. We'll talk about it just momentarily. So I'm going to start by putting my f of x up top. So I'm going to have a 2x in my numerator. And I'm going to divide that 2x by negative x minus 5. Okay? Now, we are not going to do this divided by this. So we're not going to do synthetic division. In fact, if you notice, they both have the exact same exponent on top and on bottom, which means they're not going to divide into each other nicely unless they were already identical. Okay, so I actually can't simplify this any further. You'll see in our next example when we have something that's like a power of 2 over a power of 1, what we can look for. Okay, so this actually ends up being our answer. Now, what this is defining for us right now is what we call an extraneous solution. So when you're doing division, folks, you cannot have a denominator, okay, be equal to 0. And hopefully that's familiar to you, right? Maybe you learned back in the day, if you have a 0 on the bottom, there's nothing there, so it can't hold up your numerator. I remember teaching that when I taught middle school. But the big idea here is when you divide by something, you're cutting it into pieces, right? So I can't cut something that exists into 0 pieces. There has to be at least one big piece that holds my numerator up, okay? So they're saying that our bottom function cannot equal 0, which means that x has a value that if we plugged it in would give us a 0. We need to define what that is, okay? So the way that we figure out this extraneous solution is we just take g of x, which happens to be our denominator, okay? We're going to take this negative x plus 5, and we're going to say that negative x plus 5 because that should have been a plus. Sorry about that. That was just, I forgot to write it. That negative x plus 5 cannot equal 0. Okay, so I'm going to solve this like kind of like an equation. I'm going to minus 5 minus 5. So I'll have negative x cannot equal negative 5. And my last step, divide by negative 1, divide by negative 1. I end up with x cannot equal positive 5. Okay, because if x equaled 5, negative 5 plus 5 would be 0. That's going to be our impossible solution there, okay, our extraneous solution. So when we're doing division, you need to look and see if you can simplify it. It'll be obvious, okay? And then you need to define your extraneous solution, which is you just set your denominator not equal to 0 because you can't have 0 in the denominator and solve, okay? I know that seems tricky. Again, we'll see a couple examples and you'll practice it. So let's do a handful of these problems together right now and see how it goes. So, given that f of x equals x squared plus 5x minus 2, and g of x equals 3x minus 2, find each function. So we're combining these two things into a brand new function, and we're going to look at addition and we're going to look at subtraction, and then below we'll have two other functions and we'll be looking at multiplication and division. Okay, so we'll do another set of examples. So this function is telling us take our f function, take our g function, and add the two together. So I'm just going to write it as one big addition problem. I'm going to start out with my f function right here. So I'm going to rewrite it. X squared plus 5x minus 2. And I'm going to add to it my g function right here. And again, it's in more than one piece, so I'm going to make sure to put it in parentheses. 3x minus 2. And hopefully you're thinking back to chapter 4, when we add polynomials, we just combine like terms, and we should write it from highest to lowest power. So is there any other squareds that I'm putting with it over here? Nope. So I'm just going to have an x squared. Then I have a 5x plus 3x, which gives me a positive 8x. Then I have a negative 2 and another negative 2, which gives me negative 4. There's nothing else to simplify here. I'm done. I just need to put my label in front. So I should have f plus g of x equals this. Let's take a look at a subtraction problem, okay? And you're welcome at any point in time to pause this, try it on your own, and then press play. It says f of x minus g of x is essentially what it's telling me to do. So I'm going to start with my f function. I'm going to put it in parentheses because it's more than one piece. Now I'm going to subtract from it my g of x, and that's going to be 3x minus 2. Now here it's really important that I put it in parentheses because this negative has to get distributed here and here. So it really becomes negative 3x plus 2. And now I'm ready to combine like terms, starting with my highest power. So I'm going to have an x squared because there's no other x squareds anywhere. I have a 5x and a negative 3x, so together I have positive 2x. And then I have a negative 2, and then this became a positive 2, so those two actually cancel out to be nothing. I do not need to put a plus 0, okay? So this is what I end up with. The only thing I need to do is put my label in front because it's function notation, and that tells the reader the relationship between input and output. So f minus g of x equals x squared plus 2x. Okay. Hopefully you're feeling pretty good about that adding and subtracting. It is, like I said, super duper similar to stuff that we've done in the past. And so we're maybe ready to take a look at the multiplying and dividing. Again, if you want to, give it a go on your own. Feel free to, and then press play again. So here we have f times g of x. So I'm going to take my f function in parentheses because it's more than one piece. X squared minus 7x plus 2. And I'm going to take that and I'm going to multiply it by g of x, which is x plus 4. And this is where we are really thankful we had chapter 4 before chapter 5, because I don't have to really reteach you this, right? You should know if I have a trinomial times a binomial, I need to either distribute this x here and here and here, and then the 4 here and here and here. Or I can take this x squared and send it there, the 7x here and here, the 2x here and here. Either way, once I simplify that, folks, I'm going to end up with my solution, okay? So take a second, I want you to multiply this through. I'm going to speed up the video to do all of the work here, and then I'll summarize it with you. All right, folks, so let's take a look at this problem real quick. I did go through and solve it for you. I took my x squared, distributed it across, my negative 7x, and distributed that across. Make sure you're careful for the signs there. And then I took a positive 2 and sent that across. I combined like terms and labeled it from highest to lowest power. So hopefully we're good to go. Again, this is just multiplying polynomials like you've done in the past. Let's take a look at 2b now. So this is f divided by g. The order of division matters. You need to make sure you put the f on top and the g below. So I'm going to take my f function, x squared minus 7x plus 2, and I'm going to put it over x plus 4. Now this is a division problem like you would have seen in chapter 4, right? It's a quadratic, a power of 2, a trinomial, and it's being divided by a little binomial with a power of 1, okay? So you could set this up as synthetic, you could set this up as long division, okay? But the big idea when we're setting things up in this specific chapter is we're not looking for remainders, we're looking for perfect factors, okay? So we're looking when our remainder is equal to 0, if you think back to chapter 4. One way that you can see if these two are going to divide nicely is looking to see what the factors are of x squared minus 7x plus 2. So to find the factors of that, if they're going to be nice numbers like x plus 4, we can actually just check to see if it's factorable. And the way we do that is by figuring out our two special numbers, which are found by figuring out what multiplies to be a times c and adds to be our b. So our a value here, and we're just looking at the numerator right now, okay? We're looking to factor this equation right here, or this expression, excuse me. Our a is 1 and our c is 2, so it multiplies to be 1 times 2 or 2, and adds to be negative 7. Okay, so if they multiply to be a positive, okay, but add to be a negative, they have to both be negative. So there are no two numbers that multiply to be 2 and add to be negative 7. That's not possible, which means that this is not factorable. It's not nicely divided by anything that's going to be like this. It's going to be divisible by maybe an imaginary number, maybe two imaginary numbers. Maybe it's going to have irrational answers, which is square roots that we can't simplify. Either way, something like this is not going to come out of it. So what that means is we're going to leave this as is. The only thing we have to define is our extraneous solution. And if we think about what would make this impossible, it would be if the denominator equals 0. So I'm going to take my denominator, x plus 4, and I'm going to say that cannot equal 0. And I'm going to solve for x. So I'm going to minus 4, and I get that x cannot equal negative 4. These two things combined make up my solution, okay? My actual division problem that I could not simplify, and then I have to define my extraneous solution, which is that x cannot equal negative 4. All right, folks, so let's take a look at how we can apply these functions to a word problem. So let's get started and read it. A robotics competition team is preparing for a tournament. The team's captain is ordering t-shirts for each of the members. The shirts cost $8 each, plus a one-time setup fee of $25, and sales tax on the order is going to be 8%. The team decides that the members will split the costs of t-shirts equally and that the captain and vice captain will not have to pay for their shirts. So we're going to write a couple functions and then do something with those two functions and talk about how those are related to each other, okay? So we're first going to start out by writing a function c of x. So the name of this function is essentially c, and we're going to have an x as our variable inside of it. And this has to represent the total cost of the t-shirts. So it's going to be the cost of the shirt, the setup fee, and it needs to include the 8% tax, okay? So, and that 8% tax is going to be applied to everything. Okay, that's really important to remember. So the cost for the shirts, if this x represents the number of team members, is going to be $8 per shirt, $8 per team member. So 8 times x plus that one-time setup fee of $25. Now, once we get that total, before they press enter and you give them money, okay, you need to take that and apply an 8% tax to it. Now, when we are handling percentages, okay, we can't compute with the percent symbol. Instead, we need to change it to a decimal. So 8% as a decimal, if we move it forward 2 spots, is going to be 0.08. So to find 8% of this, we would do just times 0.08. But we want to have the total and the tax, right? So this would represent our total. We're going to actually times it by 1.08. And the reason why we do 1 is because we want the total once, and we want to have on top of that whole 0.08 for our 8% tax. So this is our C of X function. The total costs for for the amount of shirts you need times $8 a piece plus the $25 setup fee times 1 and 0.08, okay, which is going to be our tax. Coming down to our next piece, they want us to write a function to represent the number of team members who pay for the t-shirts. So N is our function name. It's going to be the number of people. X still represents the total amount of people, but we know not everyone is paying for it, right? N of X is not going to equal X because the captain and the vice captain both are not paying. So technically, the amount of people that are paying for the t-shirts is going to be X minus 2. Minus 1 for the captain and minus another 1 for the vice captain. So now that we have this, we're going to do something with it. We're going to take our C function and divide it by our N function. So we're going to have, and I'm going to just put this coefficient in front, 1.08 times 8x plus 25 all over my N of X function, which is X minus 2. Now, although this numerator isn't as simplified as it could be, right? I could send that 1.08 across to both of those pieces. It's not going to change the exponent here. This is an exponent of 1. This is an exponent of 1. There's no way I'm going to be able to simplify these unless they were the exact same thing. So I'm not going to even try. I'm ready now to explain what this function represents. So I want you to think about this. This function here represented the cost, right? So it's how much it's going to cost to have the t-shirts, all the t-shirts made. Then we have this line, and this little expression here represents the number of people paying, okay? So this is how many people are going to pay. So think about that for a second. This represents the cost over people. And instead of saying over when we're doing division, we can often say the word per. So this is our cost per person when we divide those two functions. We will get the cost per person. Okay, and that's what happens when we're combining these with division. It's kind of nifty. So let's actually do some work with that. Let's say there are 15 members, okay? So I'm going to take that 15 and I'm going to plug it in here. Remember, I'm multiplying it, and I'm going to plug it in right here. So my denominator, I'm going to start there because it's easy, is going to be 15 minus 2, which is 13. My numerator is going to be, I'm going to solve in these parentheses first. I'm going to do 8 times 15, which is going to give me 120. 120 plus 25 is 145. So right now I have 1.08, because I haven't done the tax yet, times 145 all over 13. Now I'm going to figure out the tax. Okay, now if I did just 145 times 0.08, I get a little number. I end up getting $11.60. But the whole bill isn't $11.60, right? It's going to be that plus the 145. And again, that's why we do 1.08 times 145, because that gives us the whole plus the 1160. It gives us 156.6. So I'm going to take that 156.6. Again, I'm using a calculator, folks, no shame. And I'm going to divide that by 13. And I end up getting kind of a weird decimal. I get 12.046, blah, 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 blah. It's a hot mess, okay? Now, if we're dealing with money, we need to round it to the nearest penny. And if we're talking about how much money people have to pay, you're going to always have to round this decimal up, because we'd rather have a couple extra pennies than not have enough, right? If this is the minimum amount they need to pay. So each person should pay $12.05 to be able to pay for their shirt and contribute for the cost of the captain and the vice captain. Okay. And again, we ended up having to round that. We rounded it up because we needed it to be, if this is the minimum amount people pay, we need to make sure to cover this little fraction of a penny somewhere. You can double check that this is enough. We know our whole bill should be $156.60. So if I do $12.05 times 13 people, I end up getting that $156.65. So it's actually 5 cents more than it needs to be, but it covers all of that extra fractions of a penny. Now that we've seen how this applies to word problems, I want you folks to take a look at what your homework's going to be. I am asking you to do a word problem. But before you get to that, let's talk about these problems. So I'm asking you to do 4 through 13 odd, which means you're doing 5, 7, 9, and 11. Now 5, it looks like it's just 2 functions. This is actually a good amount of homework. It's a lot of work. You're going to, in number 5, add them, subtract them, multiply them, and divide them. So number 5 should actually have 4 answers. If you look in the back of the book at your answer key, it's going to give you 4 answers. Number 7 should have 4. Number 9 should have 4 answers, and number 11 should have 4. So right here is 16 problems technically. Okay, some of them should be quick, like the adding and subtracting, but we know multiplying and dividing could take a little bit of time. Please try to indicate any restrictions to the domain. That means tell me your extraneous solutions when it comes to division. Okay, so what can G not equal? Then I want you to give a go to 13. They already give you the functions. You do not have to write them yourself. All you need to do is try to figure out what they're asking you to do here and here and use those 2 functions to solve it. Okay? Give it a go. Again, if there's any struggles on this homework, I do have office hours on Tuesday, 1 to 2. You're welcome to log in, say hi, ask as many questions as you need to. I don't mind spending that whole hour going over this whole homework if that's what you feel like you need. Just let me know, okay? Thank you, folks. I'm glad to have you with me. Some of you new people, some of you people who decided to stay and kind of continue the traditional route. I think it's going to be a good rest of the year. Thank you, folks. Bye.